Ooh, that'll get you up in the morning. Let's try that again. Okay.
Hi, Murray. Hi, Murray.
Oh, hey, guys, I didn't hear you. How you doing?
We're great.
Awesome. So, what do you have in store for us today?
Haha. So today, we're going to look at networking roles, because so far we've looked at cable and wireless technologies. We've decided on a wireless technology for our network. We've installed a wireless network card into that computer over there. But before we actually set up our network, there's still a couple of things regarding the virtual topology that we have to talk about. So in today's lesson, I want us to have a look at networking roles. By the end of this lesson, you should be able to explain what a server is, give reasons why a server would be used, and explain the difference between a client server and a peer-to-peer LAN. Now, network roles fall into two categories. We have the client-server network and the peer-to-peer network. The client-server network is a computer network where many personal computers or workstations called clients are connected to one centralized, powerful computer called the server. The clients run programs and access data that are stored on the server.
Isn't that the kind of network that big companies use, where all the computers of the employees is connected to one big mainframe?
That's exactly what a client-server model is. The client is the computer at each employee's desk, and it gets its information and resources, such as programs, from the server or main computer. But there are other types of servers as well. For example, there's something called a printer server.
What's that?
So imagine what happens to a computer that's got a printer attached with dozens of other computers on the same network, all wanting to print to that same printer.
That computer is going to be so busy with all the printing requests that it'll never be free to do anything else.
Exactly. So it makes sense to make that machine handle only print requests and nothing else. That machine then becomes the printer server. In the same way, another computer is given the job of being the file server. This machine's only job is to back up and safely store all the files from the other computers on the network. Now, the advantages of a file server are: files are easy to find. They can be shared easily. Files are always available, even if users' computers are switched off. And data can easily be backed up. Now, many companies also rely on another type of server that stores information such as sales and stock data kept in a database and runs their operations. Very often, this machine's only job is to run a specific database, and it's therefore called a database server. The advantages of a database server are: all data is available from anywhere in the network. It's a specially designed computer and can be selected to run the database. Example, a computer with a lot of memory. And the database is easily backed up. So, to sum up, a server is a computer that provides a service to other users on the network.
What about things like email and the internet? Big companies must use this a lot.
Yes, they do. So, other common servers are an email server, an internet proxy server, and an intranet server. The email server provides all the usual facilities, such as address books, spam filtering, and so on. Also, quite often, the staff wants to use the same website over and over again, so the Internet Proxy Server stores a local copy of regularly used web pages to speed up access, save money, and reduce bandwidth consumption. Finally, many companies run their own private internal web services. This is called the intranet and is run from the intranet server.
Obviously, that means that a client-server network can be used on the internet?
Right. And it can also be used on local area networks.
What about a peer-to-peer network? What exactly is that?
Well, a peer-to-peer network, it's made up of a network of personal computers, each of which acts as both the client and the server. Each computer on the network can exchange files and emails with each other and access any of the other computers, although access can be restricted only to files one of the users chooses to make available.
That sounds like the type of network you're likely to find in the average home.
Spot on, Maura, it is. It's also used in small networks made up of a dozen or less computers. Also, in some small networks, every machine is equally likely to have a resource that another machine needs to use. For example, in a small home network, each computer is likely to have files stored in it that the other users want to be able to get access to. Plus, the network could be set up with one machine linked to a scanner, another one to a printer, and say the games computer linked to the internet, which the other computers would want to have access to. Now that works fine for small networks, where the number of requests to use a resource are not going to be too high.
No, there are times where my family would argue with that, especially when my cousins come to visit and they all want to play different games.
I can imagine that. Now let's take a look at the rules a server uses to govern the transfer of information across a network. We call these sets of rules protocols. Sometimes it's referred to as an access method. A protocol is simply a standard used to define a method of how connected devices and applications communicate with each other over a network, such as a local area network, the internet, the intranet. When sending data, each protocol has its own method of how that data is formatted, organizing the data once it's been collected and received, compressing the data, and checking it for errors. Although there are a lot of different protocols used across the various networks, the most widely used are TCP, now that's the protocol that the internet uses, Kermit, which is popular for use with modems, and X.25, a packet-switched protocol.
Who makes these protocols?
Well, anyone can make their own. In fact, some big companies develop their own in the hope that the rest of the world will use them. But careful thought and consideration needs to be given to the elements of a network's protocols before designing your own. Some of the things that you need to consider are the speed of the network, the method to be used to check for errors on data packets when they arrive, the method to be used to correct data packet errors, and when data packets are correctly received, what method or signal will be used to tell the other machine that the data is correct. How the receiving machine knows that the sending machine has finished sending all of the data, and what code is used to indicate that. Data compression. Does the protocol allow this to take place? If so, what method does it use?
Wow, I hope you're not expecting us to make a set of protocols for our little network.
Just relax, Morwa. This is just to give you an idea of the elements needed in protocols and how they govern the transfer of information across a network. Now, let's get back to our wireless LAN. Have you guys thought about which role your network should take?
Since we only have 2 computers, I think we should make it peer-to-peer.
I disagree. I reckon we should think big. We want to start our own computer business. I think we should gear ourselves up for when our computer business grows. I reckon we make it a client-server wireless LAN.
Well, in that case, you're going to need to install a bigger hard drive.
Well, I've got one in here. Why don't we just do it right now?
Well, it's pretty simple, seeing as you're only adding another hard drive. So, Zamo, he installed the wireless network card, so how about you, Morwa? I think you could install that hard drive. What do you think?
Okay, so long as Zama helps me.
Of course he will.
Yeah, sure, I don't mind. Do you mind just grabbing this there, right?
No problem.
Thank you. I'll just get the computer up. Okay, get the cover off. All right. Do you want to just give me that hard drive down there so I can show you what to do?
Sure.
Okay, now the first thing you want to do is put this in a particular way, all right?
Okay.
So you must have everything aligned properly. Do you want to just slot it in there? Okay, yeah, that looks just about okay. Okay, easy does it. Now you must make certain that the screws are aligned. Can you see where the slots are open there? Perfect, perfect. Now remember what I told you about screws there? The first thing that my dad taught me, to keep them safe. Here they are. Okay, do you want to put the screws in? I'll just grab the screwdriver. Thanks, Murray. Yeah, that looks awesome. Okay, now you want to put the power cable in as well, eh? Okay, so that's the power cable for the hard drive.
Make
the
sure
other
you
way.
turn it around so
the other
the
way.
black is at the top.
Yep, black on top, and perfect.
Done.
Awesome. And all we have to do now is put the casing back on. I'll just
Put
plug
the
this
power back on so
cable
that fan is going to work.
Perfect.
Wow.
There we go.
Sorted.
Great! I installed a hard drive into a computer all by myself.
Congratulations, Morwa, and well done. Well, in that case, It's time to look at today's task, huh? A home business that does company taxes has just installed a server for their 10 computers. List the advantages of a file server and the other types of servers they can install. So guys, until we meet again, don't forget, if you need some more information, simply log on to www.mindset.co.za/learn. Till next time, good luck with your studies. I wonder why there's no backslash in internet. Backslash is much more fun than a forward slash. It's just a cha-cha-cha!